All right, so let's start looking at large language models. And the first thing, by the way, which is important, many people don't know this. Maybe you do. I had people in one of the companies I consult for say, we can't run it on our own server. That would be too expensive. And I'm like, no, you can run it on a laptop. You can run it on a cell phone. You can't make it on your own server if you're doing the current way we do it, which is, as the Chinese have shown, it's invisibly stupid, but the current way we do it is to throw them terabytes of data straight from the web and say, figure out the pattern in a giant pile of garbage. And that will take thousands of GPUs and millions of dollars to train your model. But once it's trained, running it is just a simple calculation. So you can run these large language models locally. You download this thing called Ollama and then run it yourself. So I've got it running on this machine. Let me open a terminal. And in fact, I can do a lot of them. Let's start with Llama 3. Ollama run Llama 3, 3.1 I think I have. Nope, okay, let's see. It was a Llama run, let's try Llama 3. Yeah, that's one I've already got. Now this is a Mac M1, so it's pretty fast, but it's not super fast like the M3 or the M4, and it doesn't, so here we are. Now I can ask it a question like, why is the sky blue? And there it goes, giving me the kind of answer you'd get from a science textbook or Wikipedia page or something, which is fine. And as we're going to see in great detail, what it did was it took this question and it turned it into a series of vectors, a 784-dimensional vector for each word. So it made 4 or 5 data points out of it. And then it found matches in its parameters for that to predict what came next. So what it did, now Google indexes the whole web. They copy the page, they add it to a database, and they will find the page that matches your query. That's the old search engine. What large language models have done is they have scraped the whole web and they have made a mathematical model of the web with a bunch of parameters that will describe most of the variance of the words on the web. So instead of memorizing a page about Rayleigh scattering, they have examined 1,000 pages about Rayleigh scattering and made a sort of average of them all and remembered the parameters that will simulate that. So they've made a condensed simulation of the web instead of putting the whole web locally. That's what it is. So it's done this. Now, you can run all these things locally. And let's try another one. If I exit this one, I can do Ollama run DeepSeek R2, the Chinese model that got all this attention. Oh, maybe it was R1. I think that's why. There we are. Good. All right. And it should already be downloaded. There we are. So now I can ask this one, why is the sky blue? The new thing about this is a thinking model. So first it has a period of thinking where it tries to analyze your question and break it up into smaller chunks and choose a strategy to get an answer to your question. And see, it's doing quite a lot of thinking here about the model. It has to think, this whole period of thinking is new in these so-called reasoning models. So it's going to worry about this a lot. And what it's doing is it's going to consider different interpretations of the question and stuff like that. And eventually it's going to give me pretty much the same answer for a simple question like this. But what's amazing about these thinking models is they actually score pretty high on reasoning compared to humans. This one here, the one they just developed recently based on this, they said if you let it think and it gives you an answer, and then you just say wait and make it think more, it will get better. And if you force it to think 16 times as long as usual, it actually gets up to scoring like as well as like a middle schooler on things. So this process is pretty good. Now, something that is important to understand, though, is even though it says it's thinking, it doesn't have any idea what it's reading or saying. The words are just numerical vectors. It has no idea that there exists a real world, that light is a thing, that clouds are a thing. It doesn't know anything it's saying. It has no comprehension that these words mean anything. The only model that would actually comprehend that is just beginning when you put this in a robot body and then let it go out like a baby and explore the world and discover, oh, there are things out there. When you pick them up, they're real. And when you move them behind something, even though you can't see them, they still exist and things like that. There's just, the first experiments are just beginning where you do that. If they don't live in a body, they don't even know there's a world out there. They're just like playing games with the numbers. You give me some numbers, I do a calculation, have some numbers back. I have no idea that I've actually said anything, or that it means anything to anybody, or that it would have any consequences. So anyway, you can run them locally, and that's a fun thing to do. You might want to do that. It's good to play with them. To be fair, I'm running shrunken versions of the model locally here. The full model would take a more powerful machine with some GPUs, but it doesn't take anything like the power it takes to train them. All right, but what you really want is you want a retrieval augmented generation model. This is what all the people I consult for want. They don't want ChatGPT, which just remembered all the information on the web. They want something that they can add their company data to, their specific proprietary data, and then have it help them search through and use that data. And the original technique that I thought I was going to use for that was retraining the model. And I should say some things about this. That turns out to be very hard to do. They call it fine-tuning, retraining your model. There are two huge problems with it. The first one is the cost. Like I say, training the model takes 1,000 GPUs and an incredible amount of money, so training it on more data would be expensive. The second thing is the problem called catastrophic forgetting. If you train a model to do something new, it forgets what it previously learned. It's like Sherlock Holmes imagined his brain to be. You know the Sherlock Holmes story? Yeah, Watson tells him that the moon goes around the earth, and she said, "Shut up, I don't want to hear that. I don't need to know that. And if I remember that, that's going to crowd out something useful that I could have remembered." And machine learning models are that way. The new information erases the old information, like the security boundaries that they put in there, like don't tell people how to make a poison or a bomb. Yeah.
Can you make one LLM talk to the LLM version before it?
Make one to do what?
One LLM talks to an LLM like the version before it learned.
Well, the question is, can you take one LLM, talk to the one before it? Well, yeah, that's essentially what DeepSeek did. They took a previous model and used it to make questions to help train the new model. And one thing you can do, and they often do, is to use one to protect another. You can have an LLM trying to decide, is this question in a suspicious category? If so, then don't process it. That's, I think, what Microsoft is doing, although I'm not sure. But yeah, that's an issue. Anyway, but the catastrophic forgetting is a big problem, right? If you train it on new data, it's going to forget the old data, and that has not been solved. Now, one attempt to solve it is to only train the last layer and not the intermediate layers. There's an assumption people like to make about visual processing, and for that matter, cognitive processing. Like I mentioned before, the way I would make, let me go back to this picture where we were analyzing an image here. I think it was this one will do, actually, when we're classifying these clothing images. All right, remember I talked about this. You take the input image and you just process each pixel independently. Now, the model of human vision, this used to be my field, you would imagine that you process this to find edges and stripes, and then you have those higher order constructs, like an edge, that you then work on. That's the idea. So we believe that the lower layers of the brain, like the photoreceptors in your eye, are doing simple things like finding edges and lines, and the later receptors are making more and more meaningful things. Now, that is not really true in practice. When you stick in a probe and look at it, it's not that simple. It is, but you imagine that. Large machine learning models have made similar guesses that the first few layers are probably just finding local correlations, like this pixel is near it, and the later ones are looking at bigger picture ideas. And they think this might be true at a cognitive level too, where lower levels are analyzing single words, higher levels are analyzing sentences, higher levels are analyzing paragraphs. And therefore, if I wanted to remember about words and sentences and paragraphs, but I want to teach it like about my company data, I'll just train the higher layers and not the lower layers. That's what people tried. It didn't work out too well because both in the human brain and in large language models, it's not that simple. It is not true that each layer does something understandable and at a different level than the previous layer. It's all sort of mixed in the different layers. So that's why retraining your model on company data did not turn out to be a hit. But what did turn out to be a hit is retrieval augmented generation. This is why Copilot uses it. This turns out to be better. Rather than trying to retrain your large language model on company data, leave it the way it is, and then add the company data to the question, which is why I say they're proud of having like 100,000 tokens, 200,000 tokens input. The modern large language models can take a whole novel worth of question. And I wondered when I first said, why would you do that? The human's asking a question, it's only like a few sentences. Why do you want this huge input? And this is why. You add tons of contextual data. Then they call it retrieval augmented generation. And so you can make a few versions of this to see how it goes. You can make your own in Python. Here's a simple one. I have 10 possible activities. Take a leisurely walk, visit a museum, and so on. Then I calculate Jacquard similarity, which is also called Manhattan distance. I ask the user a question, and I just say, how many words in your question match a word in the answer? And if there are more words in your question that match the answer, I'll give you that answer. This is like a really primitive search engine, like Alta Vista. So there's no large language model at all. So if you run this and you say, I like to hike, it says, take a walk in the park and enjoy the fresh air. Then you say, I don't like to hike, and it says, go for a hike and admire the scenery, because the word hike is in here and the word hike is in there, and that's all it knows. There's a match in the word. It's not smart enough to understand what the word don't means. So it gives you the wrong answer. So now you can add a large language model to it. You run it locally in Olama, and in addition to having the interaction I showed you, it's now listening on the API locally. So you can add to your code something that's going to call the API and analyze the input. And it's going to print the whole story out here. So when you run it, if I say, what is a leisure activity you like? I say, I like to hike. Now, it does not process that prompt. It creates a new prompt by adding data. And this is how they all work. They add extra context to your data. So Ed, you are a bot that makes recommendations for activities. You answer in very short sentences and do not include extra information. This is the recommended activity. Go for a hike and admire the natural scenery. The user input is, I like to hike. Compile a recommendation to the user based on the recommended activity and user input. This is what's really happening with all these large language models. You're putting in some data like this, and it is adding a bunch of context from the administrator around it, which attempts to enforce rules like don't tell them how to make poison, don't tell them how to make a bomb, don't talk about sex or anything like that. Those are all rules. The problem is they're all just treated as suggestions. None of them have the authority that you would like to have from like administrator commands, because there is no logic that has like if statements that always work. They're just added to the data just like the rest. And so, for example, if you want to override the administrator's priorities, rambling helps. If you just add more words asking for what you want, then there's more data points over here, slanting it that way. So just rambling, repeating yourself, going on, means you'll have more likely to listen to you than the other. Anyway, so now here's the result. Great, based on your interest in hiking, I recommend going for a hike. Now, if you say, I don't like to hike, this is the prompt, and now it's smart enough to catch on, because now the large language model is able to notice this word don't here, which the Jacquard similarity is not. So that shows the fundamental principle, and now you can make even a realistic one. You can download, I took one of the National Institute of Standards documents about AI security and formatted it so you can just download it. There's like 80 risks of AI. And now you can ask a question, and you'll see it says, you are a security expert working for the government, give an accurate answer, base your answer on this context. So when you ask a question, it will look for keyword matches in the list of 80 known AI risks, and it will add the known AI risks from the list of AI risks to the question, and then include your input, and then it will give you an answer. So I'm worried about world domination, and it will give you what I thought was the right answer. World domination through AI is purely fictional. Anyway, but that's the game. By the way, another thing to realize about these, which I haven't mentioned, is they have a coefficient called temperature. The original AIs, the original models were greedy models, where it would always choose the best possible word. And then there are two flaws. It always gives the same answer to the same question, and it tends to get stuck in loops, just repeating 3 words over and over and over. So they added just random noise to it. So it will sometimes not choose the most likely word, but the second or third most likely word. So it gives the appearance of variety. That's what's going on here. That's why if you're trying to do a jailbreak of an AI to trick it with prompt injection, one good thing is just try the same prompt again a few times. Often it will work sometimes, but not every time. They are not deterministic. That's why you can't put in any security boundaries that actually work. So that's retrieval augmented generation. Now let me stop this recording. I'm going to sort these up later.